Hello everyone, this is Ahmed Hashala speaking. Today I'm going to talk about how to use machine learning to improve project budgeting system. I work as a program manager in industrial automation field, so I try to spot a real uh, business problem in order to resolve by doing my research. So let's get started. Let me give you a brief background about a project lifecycle. A project starts when a company or a government known as owner calls for a tender. Accordingly, contractors receive the tender document, study the document, and provide technical and commercial proposals. Consequently, the owner selects the lowest price, providing the L1 offer is technically approved. Okay, where is the problem then? The problem that unfortunately not all informations are available during the bidding phase, so the bidding team should make a lot of assumptions. Some informations will be revealed only in the engineering phase. And there is a business need to have a, a quick, dynamic, flexible budget system in order to overcome the insufficient classical budgeting system. The company needs to balance between providing a high price or a low price. Providing a high price, the company can lose opportunity in the first place. Providing a low price, the company, or too low price, the company can win the opportunity, but they will face difficulties during project executions, which will negatively impact the customer satisfaction, and both cases can jeopardize the business sustainability. So, how to use a machine learning? The machine learning is a branch of artificial intelligence. It tries to mimic human brain. So, it uses historical data in order to build a model. So, no explicit programming required. Just we need to provide a clean and accurate data, and the machine learning can build a model to forecast uh, the dependent variable to build a relationship between features and deliverable. Recently, machine learning is used in many different fields, including pharmaceutical, entertainment, and management. We can classify machine learning techniques into supervised and in unsupervised machine learning techniques. Here I used five supervised machine learning techniques, including multilinear regression, artificial neural network, nearest neighbor, random forest, and support vector regression. The first step in building a model is data processing. So I received different 500 plus projects executed in different countries, including Egypt, Saudi Arabia, Qatar, United Arab Emirates, Kenya, and Tanzania. So I received the data in different format extracted from Microsoft Dynamics. So I need to uh, transfer that data into my format in order to facilitate building a model. For example, I received 53 cost categories. I cannot add 53 independent variable in my model. It will make that too complex. So I aggregated the cost categories into 9 cost categories, including material, engineering, logistics, finance, risk, services, overheads, installations, and others. Then I scaled the data from 0 to 1 using RStudio. By the way, I used R language to build my models. Then I split the data into 70% in order to train the data, which is called training dataset, and 70% to assess the accuracy of the built model. And here we build a model. We can visualize the data. I use Bearplot to visualize the cost categories from one side and the actual cost. As we can see here, the relationship is obvious between material and actual cost. It is non-linear, yes, but there is somehow material. We can spot also a relationship between finance and risk. I need to mention that failing to identify a pattern by our Bare eyes does not necessarily mean there is no relationship. So I built different models, and here is one example of artificial neural network. We have 9 inputs as stated, and we have here in this particular model we have 3 hidden layers. In first hidden layer we have 5 neurons. Second hidden layer we have 6. Third we have 2, and we have the outcome, which is the actual cost. I need to mention that we need to balance between being too complex or being overfit and being too simplex or being underfit. Here is also one good point about using the machine learning. Machine learning can identify the importance of each variable, which one exactly contributes much into forecasting the actual cost. As we can see here, material is very important in forecasting, comes after that services, overheads, and come at the end, finance and installation. Then I compare the model using root mean square error. The red one is for the testing data sets, and the blue one is for training data sets. So, okay, as we can see here, the deep learning provides the best fit or the lowest root mean square error in the testing data set. And we have here the KNN is providing the lowest root mean square error in training datasets along with RF. Our main concern is the test for the sake of generalizability. Okay, in order to make a conclusion, so I did an over test to compare the groups, the machine learning groups in one side and the classical from the other side. As we can see here, there is the p value is less than 0.05, so there is a statistical significance between using the machine learning and the classical budgeting system. So after that, I did a two-key post hoc in order to identify which model exactly provides the best forecast. We have here ANN provides the best forecasting. Comes after that the KNN and multilinear regressions come. We can conclude that ANN and KNN are significantly different from the classical budgeting system. The random forest using Carrot library provides the best fit for training dataset. The deep learning using H2O library provides the best fit for test, which is our main concern. What is the implication of that research? Okay, we could conclude that the machine learning can improve a budgeting system. We can focus on the most critical factors. We can build a benchmark to identify if or to spot if there is overestimation or underestimation in the project budgeting. Generalizability. The good thing about this research that I provided a methodology. I'm not providing a solid case study. So I built a model which can fit in different industries, in different companies. The cost categories may different. For example, a consultant may consultant does not uh, have installation cost, but they can have different cost categories. And also, I build a methodology to validate or to assess the accuracy of each model and to compare to the actual data in order to identify the worthiness of using machine learning. In some cases, on some companies, the machine using the machine learning may not help. Here is a future researches which I need to talk about. I also am seeking for a co-workers who can I pursue my research. We can validate the result using different companies, different industries. We can use different cost categories, and also we can remove the least essential cost categories to identify if by removing that inputs, what will happen to the actual cost, how that will impact the forecasting accuracy. We can also identify a relationship between cost categories. For example, we can say the installation cost can be like 10% of the material cost. That will really benefit the bidding team to minimize their effort and minimize the time consumed for building a budget. Uh, and also we can build a different model for each cost categories. For example, we can build a model for forecasting the engineering hours, the engineering cost. So, in other words, we can transfer or we can uh, change the engineering from being independent variable to be dependent variable and build a model to forecast the engineering cost, and the forecast of the engineering cost will be an input for the actual cost. Uh, we can also try to make a forecast for installation, for the cost of finance, and etc. etc. Thanks for watching.